Hi, to start off with this new unit, we're going to first review the equilibrium that we learned in honors chemistry. Now, in honors chemistry, we learned that if a reaction goes to completion, a one-way arrow is to show the reaction, like HCl gas makes H plus aqueous plus Cl minus aqueous. Now, there are also reactions that does not go to completion and instead go to equilibrium, and we're going to show that with a double arrow, like 3H2 plus N2 makes 2NH3. Now, this double arrow is used to show that forward reaction rate equals reverse reaction rate. In honors chemistry, we learned that the equilibrium constant, KEQ, is equal to product to the moles power of the product divided by reactants to the moles power. Now, in this unit, we're mainly going to talk about Kc and Kp. Now, Kc and Kp are all varieties of the equilibrium constant, but they represent just different things. Now, one key note to remember is that solids and liquids are not included. Solids and liquids are not included in this formula. Only gases and aqueous. Now, we also learned in honors chemistry that if K is greater than 1, that means products are favored, which means forward reaction favored. If K is less than 1, that means reactants are favored, which means reverse reaction favored. If K is equal to 1, concentration of products equal reactants. Now let's talk about Kc and Keq. Kc is a ratio of concentrations, and this is Kc is equal to ratio of concentration. So it's going to be concentration of products to their moles power divided by concentration of reactants to their moles power. Kp, on the other hand, is a ratio of partial pressure. And similarly with the same formula, except a little bit different. Kp is equal to the partial pressure of products to the moles power divided by the partial pressure of reactants to the moles power. Now notice how concentration is used with a bracket and everything else is used with the parentheses. And during the AP exam, you have to represent concentration in brackets.
So now after we learn Kc and Kp, we want to learn the relationship between Kc and Kp. So to find the relationship, this is the formula. Kp is equal to Kc times RT and to the power of change of n. Now, R is 0.05206 or 0.0821, and this is the gas constant that we learned a few units ago, the gas constants. And this is, if you recall, this is the gas constant when it's atmospheres. And in this unit, we'll be mainly using atmospheres. So this is the number, this is the gas constant that we'll be using for R. T will be temperature in Kelvin. And finally, changing N is the moles of gas product minus moles of reactant. No, minus moles of gas reactant. Now, if you take a look, if the number of moles of gas product equals moles of gas reactant, that means this will equal to N. And that means changing N will be equal to 0. And anything to the 0th power will be equal to 1. So when moles of gaseous product equal moles gaseous reactant, Kp equals Kc. Now that's it for this video, and in a few videos we'll be doing some practice problems with Kc and Kp. Thank you for watching.